the square. Completing the square. So this whole unit 4, has all been about solving quadratic equations. And what we've seen are two different ways so far to solve for x. We're just trying to find out what is x equal to. This is our third and newest way to find the solutions, find what x is for a quadratic equation. So we'll start this in just a second, completing the square. Before we do, I want to do a warm up with you. So wake up, turn on those thinking caps. Let's say that we set x or some variable equal to something. So let's suppose, for a warm up, suppose that x is equal to 5. Suppose this is true. Then if we said this instead, if we said x is equal to 5, but we added something to both sides, like plus 3 on the left and plus 3 on the right, what is x equal to now? Is it still equal to 5, or did I change it when I added the same thing to both sides? Tell me, what do you think? What is x equal to now? Is it still equal to 5, or have I just changed it?
I feel like you changed it, so we'd have to find what x equals now.
Okay, I like where you're going. Continue with that, Braden. Try to find what is x equal to now. Because we did change it, right? We added 3 to both sides. So keep going, keep digging down that path, and tell me what you think x is equal to.
Okay,
Not just you, but all of you. So keep going. Do that. This is not Braden's job just because he answered.
Do you add the x to 3, making it 3x?
It would be 3x if we multiplied it. But because we added it, they're going to stay separate from each other, like x plus 3.
Okay.
Braden, I'm glad you're working on this. I just want to make sure other people are too. So, Manaya, what'd you get? Did you solve it for x yet? What is x equal to here in the center of the screen?
I didn't finish solving it yet.
Okay, keep working on it.
Yeah, I'm still working.
Janessa, let me know what you think.
Joseph, I was wondering, a little bit after class, could I talk to you just for a couple minutes?
I have my Math 1 class right after it. So we can talk at like noon if you want to join me at 12.
Yeah, that's fine.
Okay. So
Thank
jump
you.
back on the call at 12, okay?
Okay.
Awesome. Laser, since we're talking now, try to solve this equation. X plus 3 equals 5 plus 3. Solve that for x for me. What do you get?
Don't you just get 5 because those 3's cancel out? Ooh.
Oh, Manaya, you're hurting my brain. Explain. You're right. You're right. X, it's still going to be x equals 5. Walk me through your process, your mindset on that, please.
I didn't really do a process. I was just looking at it. I remember back in lesson two, unit two, you said that if there's two numbers, they cancel each other out.
Two numbers on both sides of the equal sign, right? Like
Yeah,
plus three,
it's
plus
the
three.
same.
Yes. So let me try to kind of just walk through what I think maybe you're doing without like making it into steps. X plus 3 equals 5 plus 3. Manaya is saying they should cancel out. Let's see if they do. How do we isolate the variable x? We should know this, guys. It says x plus 3. I want to get it alone. So we want to cancel that plus 3, right? How do I cancel plus 3? Who said that?
-3.
Oh man, I'm hearing like 3 different voices at once saying minus 3. Love it. To both sides, right? Minus 3, cancel. And then on the right side, it also happens to cancel this guy out. And lo and behold, we're back to where we started. X equals 5. The reason I wanted to point this out and make a big deal out of it this morning is I wanted you to remember this concept. If you're adding the same thing to both sides like we did here, plus 3, it doesn't change it. It's still the same statement as what we started with. X equals 5. Now I want to show you one more version of this. So warm up number 2. You know what? Let's just do the same thing with x equals 5. So suppose x equals 5 again. Let's say we did it a slightly different way. Let's say I wanted to fool around with just one side of this equation. So what if I did this? It's still x equals 5, but I went ahead and did a plus 4 and on the same side, a minus 4. What are your thoughts on this? Have I changed x? Is it still going to be x equals 5? So just to make my question, just in case I'm not being very clear, what I'm asking is x still equal to 5?
Isn't it yes? Because don't you just still subtract the fours?
Totally. We combine, we are subtracting 4 minus 4, the ones I just threw in there, right? If we simplify it, what Manaya is saying is we just combine these two, they cancel. 4 minus 4 is 0. We don't need to show that plus 0, right? We can get rid of that. So it's just x equals 5. So again, my point is, if you add something to the left and subtract the same thing from the left, like I did here, it doesn't change what we started with. And that's, even though it seems weird, it's okay to do because we haven't changed the original statement. We're going to need to use this skill as weird as it might seem. We're going to need to use this to complete the square today. So back to our quadratics. Here's our real example 1 for today. Just like this whole week, the only goal, the only prompt is to solve the quadratic equation for x. Solve for x. Find the solutions. Here's our quadratic. X to the second power minus 6x plus 2 equals 0. So it looks just like our regular quadratics, yes? Nothing too crazy. However, we're going to find that not all quadratics that exist out in the world, out in math land, can be solved using our lists. So here's the question for today that goes with this new skill is, what do we do when making the lists doesn't work? Now, we haven't even tried yet. I've kind of given you a hint. It's not going to work in this case, but I want to show you. Let's say I sat down to do a mastery test and I get this quadratic at the top and it says, find the solutions of the quadratic. And I'm like, okay, no problem. I'll make a list to multiples of a times c, which in this case is 1 times 2, so 2. And it has to add to the number in the middle, remember? -6. Add to b, which is in this case -6. So I start making my lists. 1 times 2. And there's no more. There's no more numbers that multiply to make a 2. Okay, no more whole numbers that multiply to make a positive 2. And if I try to like add those together or minus those together, because we have a negative in this case, so like 1 minus 2 or -1 plus 2, neither of, or I guess we actually want, it's a positive 2, isn't it? So you know what, let me cancel those out. It would have to be -1 minus 2 or just straight up positive 1 plus 2. Either way, we're not going to get a -6 out of this. We get a -3 or a positive 3. We haven't come across the case like this yet where making the list doesn't actually work. And I double checked my work. I didn't miss anything or copy something down wrong. We're following the process and it didn't work. So this is a case where we have to do what's called completing the square. Complete the square. So get ready. This is kind of a process. But the math we're going to do is not really anything new or crazy. It's just a new process that you haven't done before. Completing the square. So x to the second power minus 6x plus 2. Let's get a new screen. Equals 0. And our goal is just to factor it like normal. X is equal to some numbers. That's what we're trying to find. But we tried making our lists and it didn't work. So here's what we do. Step 1 is get the X numbers alone and the not like the C number on the other side. So for our step 1, let's say move C, if there is one, to the other side. Meaning move it away from the X's. So let's do that now. So to move it, we have to do the opposite. Remember, we can't just drag the 2 over to the other side. We've got to -2, -2. We're canceling it out, basically. What are we left with? X squared minus 6x equals -2. Okay, so now we've got our X parts all alone on the left. X squared minus 6x. Okay, step 2. Find the B number. It's -6 in this case. Find or identify B. We're going to cut B in half. That's the same thing as dividing it by 2, cutting it in half. So our B is -6. If I cut that in half, cut in half, is -3. Step 3. Square that new B number we just made, the half number. So I'm going to say square the new quote unquote B. So we have -3, right? If I square that, what do we get? -3 times -3. What do we get for that? Anybody?
9.
9. So it's a positive 9, right? Thank you. There's our new weird number we just made. we're going to add this to both sides. So let's do that now on the left with our actual problem. So x squared minus 6x plus 9 equals negative 2 plus 9. Why are we allowed to do this? Because we're adding it to both sides. So if we were to rearrange the whole thing back to how it started, we really haven't changed anything. Remember, we can minus 9 from both sides and kind of get back to what we just had. So just like the warm-up, we're allowed to find this special number, plus 9 in this case, and add it to both sides. Now, on the left, we've got this new quadratic. See that? We've got x squared minus 6x plus 9. We went through the process in step 2 and step 3 to find what number we were going to use here. It turns out it's 9. It will be different every time. On the right side, we can actually simplify those. We can combine them, add them together. So let's do that now. Step 4 is to factor what we have on the left and then combine whatever's on the right. Combine those negative 2 and plus 9s. So let me write that down. Step 4, factor the left like normal. It'll work this time. And then combine or add the two numbers on the right. Okay. Now, if we, on the right, we're going to get 7. Negative 2 plus 9. Now, on the left, though, our new quadratic, this is not just any quadratic. It's actually a perfect square quadratic. So we did this a little bit. I forget which unit it was, either 1 or 2. It must have been unit 2. But we did look at perfect squares before, and that's when we have, let me show this on the side note. Perfect squares when we have like x plus something and it's squared. So it's like two of the same parentheses basically. X plus a number squared, or it could be x minus a number squared. Same thing. Those both count as perfect squares. We have that going on with our quadratic, x squared minus 6x plus 9. We actually made it that way by doing these steps, step 2 and step 3, when we cut in half and then we squared it and then we added it to both sides. So we've just forced this thing to be a square, and that's why this is called completing the square. We just like took our original problem and kind of rearranged some things and forced it to be a perfect square. So if we go through our list process with 9, we could get 1 times 9, 3 times 3, and we find, okay, negative 3 multiplies together to 9, and they add to make a 6, a negative 6. So I'm going to skip that step here because we've done an awful lot of making lists. And if we remember how to do the perfect square shortcut, we get straight to this, x minus 3 squared. The two parentheses, if we showed it all, would be x minus 3 times x minus 3. So we have x minus 3, the whole thing, squared, equals 7. I'm going to wait like 10 seconds in case people are still writing. And we'll finish this up. Remember, the goal is to find x solutions. What are the numbers for x? And we're almost there. What we're going to do next is combine what we're doing today with what we did in the very first lesson of Unit 4, which is solving with square roots. Remember when we take the square root of both sides, and then we have to do the plus minus of the square root? We're going to do that now. All right, here we go. Just continuing the same problem. X minus 3 squared equals 7. So I want to find out what is x. Since I've got this bundled as a parentheses squared, we can clean it up by taking the square root of the whole parentheses squared and the 7. Now remember, from this first lesson and from I think unit 1, we did this as well. Square roots cancel squaring. So essentially, our squaring and our square root on the left are undoing each other. We're left with x minus 3. On the right, if we take the square root of a number, we have to account for the positive and the negative version of it. This should look familiar from our lesson from last Thursday. It's the first lesson in Unit 4. Taking the square root yields the positive and the negative version. Almost done. We wanted to say x equals, not x minus 3, right? So get the x alone. Add 3 to both sides. On the left, they are canceling. On the right, we've got 3 plus or minus square root of 7. Now remember, the plus or minus symbol, that means both of them. So it's like, really what it means is this. Here's our answer, here's our solutions for x. X is 3 plus square root of 7, and x is 3 minus square root of 7. And this is the reason that making the list didn't work from the very beginning. This is like an actual legitimate number answer for x. However, I can't find the square root of 7 on my number line, right? I can't find the precisely on the number line. If you take the square root of 7 in your calculator, you're going to get 2.645751.3. It goes on forever. It's an irrational number. And they don't exist precisely. It exists mathematically, but it doesn't exist like on the x-axis. So the reason it didn't work to make a list and factor this problem the normal way is because it was kind of destined to have this square root of 7 in the answer. And so we have to find it using this other way, completing the square. I hope you've got those steps written down in this example. Does anyone want me to go back to show the other screen and get the steps or the beginning of the example?
Yeah,
I
can you
don't
go to
really
the
want to
other
see the
screen real quick?
step.
Sorry, guys. Laser, go first.
I was gonna ask is like after you showed the examples, could you do another example?
Of course. Totally. Yeah, we'll do another one in just a few moments. Braden now. Yes?
Can you go back to the other screen real quick,
Here we go.
please?
Yeah. So this is just the beginning of that example with the steps written. If you're having trouble seeing or reading what I wrote, let me know.
All right, thank you.
Yeah. I'll wait here for a few moments, and then we're going to look at a new example doing the same thing. I'm not going to write the steps each time, okay? So if you want to take a picture of those steps or finish writing them, do that now. We're going to use the steps, obviously, but I'm not going to write it every time. It's a lot to write. People are dropping off like flies here. Let's do another one. Example 2. Remember, the goal is just to solve for x. So we want to say x is something, x is something. We're looking for those solutions. But if the list doesn't work, we have to do completing the square. All right, this one starts like this. 4x squared plus 32x minus 28 equals 0. Okay, now in the last 2 days of lessons and homeworks, like last Thursday and then Monday and on our review day yesterday, we saw quadratics like this where it has a number for a, which is 4, and each of the other numbers, the b and the c, are all divisible by 4. So if that's the case, let's start by cleaning this up and making the numbers smaller to start with. This will be better. So basically, I look and say, oh, this has a 4a number. So I ask myself, can I divide 32 and 28 by 4? If it works, yep, then we can clean this up. So let's do that. Start by cleaning it up and dividing by that a and getting x squared plus 8x minus 7. And I'll make a note. We divided everything by 4 to start with. Always do that if you can, because it'll make it easier to work with. We even divided the 0. We had to divide everything, left and right side, by 4. Okay, now we jump into completing the square. Let's just say I didn't know I had to use completing the square. Let's try doing this the normal way. Let's start making a list. Multiplies to -7, because I want you to see what it's like going through and finding, oh, it's not going to work. That's weird. That's our clue. We have to use completing the square. And it has to add to +8. So to multiply to a 7, it has to be 1 times 7. To make it a -7, though, that's our clue that one of the numbers is negative. So that means we are adding -1 plus 7 or 1 minus 7. And when I try adding those, we get 6 or -6. Do you see the problem? There's no way we can have two numbers multiply to -7 and then add to a +8. The only things they can add to is 6 or -6. So in short, I'm noticing the list doesn't work. Uh-oh. So that means we're going to have a square root, irrational number in our answer. So that means we're going to have to use completing the square to solve this. All right, here we go. So now we start doing our steps. Let's get the -7 away from the x numbers. How do we do that? I'm going to add 7 to both sides. It's -7, right? So we want to add 7. So we're just moving it over. It becomes equals +7. Okay, then for step 2 and 3, we're examining b, which is 8. I cut that in half. So side work here. 8 cut in half is 4. We're not done. We take that number and we square it. So 4 squared, that's 16, right? So that's the number we're going to settle with. We're going to add that to both sides. So I'll do that below. So x squared plus 8x plus 16 equals 7 plus 16. Okay. At this point, on the left, we've got x squared plus 8x plus 16. This is a perfect square. We just made it that way. Now, if you wanted to, you could solve this. You could factor on the left using lists, meaning numbers that multiply to 16 and add to 8. If we did it that way, we'll get 1 times 16, 2 times 8, and then 4 times 4. And if we play around with those, we'll find the only set that works is 4 plus 4. That gives us the 8. So essentially, we're splitting up our 8x into 4x, 4x. We're factoring the left and right, and we finally get to this. X plus 4 squared equals, what's 7 plus 16? 23, I think. 23 equals 23. Here's a little shortcut that you might have noticed in the last 2 examples so far. Back up to when we took our 8 and we cut it in half, we got a 4, right? Over here. Over here, we took our 8, we cut it in half, and we get a 4. Basically, folks, whatever that number is going to be in our parentheses. It happened in the first example as well. And that's something you could count on. We still have to find the 16 and add it to both sides because we have to add the 16 to 7. Otherwise, this will give us a wrong answer. But once we do the middle number 8, cut it in half and we get 4, you can use that and jump straight to x plus or x minus that squared. No questions or concerns yet? Okay, so we take a square root of both sides now. So technically, I'm taking the square root of that whole left side. Of course, the squaring and the square root box are canceling each other. And I've got to take the square root of 23. And don't forget that when we take a square root of a number, it gives us the positive and the negative. So I'm going to write it as plus minus root 23. All right, we have x plus 4 equals plus minus root 23. And if I move my 4 over to be with that plus minus root 23, this time we have to subtract 4 from both sides. Let me just change my color here. Okay, so we subtract 4 from both sides. Minus 4 and then minus 4. So what are we left with? We've got, I'll put it on the left where there's more blank space. We've got x equals negative 4 plus root 23, and x is negative 4 minus root 23. And there's our two solutions. Any questions, concerns, anything you notice that you want to share? Please. I know people are probably having questions. It's okay to ask. I want you to. The more you do it, the faster and the easier it'll feel. I know at first it's going to be crazy. And it honestly took me a long time when I was your age and starting to see this stuff myself. It took me a long time to really understand it. And at first, I just had to kind of trust the steps and keep plugging away. And later in life, I was like, oh, I get it. It took me a while to like actually get it. But the point is, we're forcing our original problem to be a perfect square to get to this x plus 4 squared business down here. We're forcing it to be like that. Because really, look back at the original problem. There's no 23, right? There's no 23 there. Where did that come from? Well, we changed our problem by adding 16 to both sides. So we did change it, but we were allowed to, right? Because we did it to both sides. And that basic concept does make sense. You can add the same thing to both sides, and that's okay. So we're not breaking any rules by doing this, but it is kind of a workaround. Okay, I'll hold on the screen for 10 more seconds. Let's do another example. And then there's one last really smaller topic I want to talk about and show you. And then we should be done for today. Okay, here we go. Example 3. Find the solutions of the quadratic. And here it is, negative x squared plus 4x plus 12 equals 0. Okay, so let's just go straight to completing the square. However, this one's also a little different than normal because look at A. The A number is -1. So I don't really like that. We want to work with a positive A. We've worked with quadratics with negative B and negative C, but we want our A to be positive. So let's start by multiplying the whole left side and the whole right side by -1. A little like front loading work here to get it ready to work with. So multiply everything, front and left, left and right side, by a -1. That's going to change the sign for everything. That's going to make this x squared positive, and then minus 4x minus 12. And 0 times -1 is still 0, so it's just equal to 0 still. And now we're ready to get going. Let's complete the square. So we move our -12 over here. I can't just drag it though, right? We're going to add 12 to both sides. So plus 12, and we get x squared minus 4x equals 12. Okay, now is when we start working with that b number. This time b is -4. So here's my side work. B is -4. What do we do first? We cut it in half, and that's -2. So here's a little hint. -2 is what's going to be in our parentheses later. Okay, we can kind of shortcut that if you want to. However, we still need to do the squaring and add that to 12. So -2 squared, well, that's +4. That's the number we add to both sides. So +4 plus 4. And what do we have? X squared minus 4x plus 4 equals 16. Remember, we are kind of doing side work. We're examining B. The original B is -4. We cut it in half, we square it, and then we add that result to both sides. And that's what I've done here. We added 4 to both sides. Now, on the left side, I'm going to write this down. We want to factor this. And we've already added on the right. We made it a 16. Now, factoring this, it's going to be a perfect square. That's what we've been doing here today, is forcing it to be a perfect square. And we can use our shortcut. When we cut B in half, that result, -2, is what's going to be in our parentheses. So it's x minus 2 squared equals 16. All right, hopefully lesson 1 from unit 4. Last Thursday is when I did it with you guys, and then we reviewed it yesterday and did it. Some of us did it together in class. Some of you already did it before that. What do we do in that first lesson? We take the square root of both sides, and the 16, a number getting taken the square root of, has to be positive and negative because they both work as the square root. So what do we have here? We have x minus 2 equals plus minus square root of 16. Now, we would move our 2 over. The minus 2 needs to move over to be with the square root, right? So we're adding a 2 to both sides. Plus 2 plus 2. So I'm ending on the left of the screen here. We have x equals 2 plus square root of 16, and x equals 2 minus square root of 16. Now, this problem actually doesn't have an irrational number in it. The square root of 16 does become a simplified whole number. So that means that we actually could have used our lists for this problem. But it's okay, because completing the square will help us solve any quadratic, regardless of whether it has the irrational number or not. So let's clean this up further. Square root of 16 is 4. Maybe some of you caught that. So if I were to simplify those to 4, 2 plus 4, 2 minus 4, that's 8 and negative 2. So our solutions here were 8 and negative 2. Okay, so solutions on the left in the box. Now, if it's telling you to use completing the square, normally it's not going to come out to a whole number. Normally it won't give you like square root of 16 or square root of 25 or square root of any like perfect square number. But I did see a couple in the mastery test for today that do this. So if you get a whole number answer, it doesn't mean you did it wrong. It just means that we could have actually used lists like the normal factoring method to solve it anyways. All right. I really hope you guys you folks are trying this with me and not just watching. I guarantee you're not going to remember it if you're just watching it. Nothing personal. It's just the way it's too complicated to like remember all this and not really do it. So I really hope you're trying to follow along and just do it with me. And there's one last mini topic I want to talk about quick because it's going to pop up in the mastery test. Just in case, if you're feeling like really stuck in the woods or lost in the woods on this completing this square, I would recommend you to go onto YouTube today or Khan Academy. I know a lot of people like that. And watch some more examples. Just spend 10 minutes or so, maybe at least 10 minutes can't hurt you. Go to YouTube or Khan Academy and search for completing the square. It'll be good to see someone else other than me doing it. And again, I would have you follow along, completing the square. So get some paper, try to do it like on your own and then using the video that you find. I'll put my own video up on YouTube as well, but go see other people's. That might be helpful to get some extra like support and practice. Okay, but for our other mini topic, for some reason, this mastery test is emphasizing minimum and maximum values of our quadratics. Minimum or maximum values. Now, this isn't actually really new, but I don't think we've talked about it as a minimum or a maximum, except maybe the very first day we did a graph of them. So when we were graphing quadratics in Unit 3, so for example, step back to this world with me when we graphed these things, and we got our parabola shape. When we have a downward facing parabola or quadratic, then the vertex is the highest part of the graph, right? It's the highest part of the function. So here the vertex is a maximum, right? The vertex is the maximum like number, the maximum value of the whole quadratic, highest part. And likewise, if we have a normal upward facing like this, then the vertex is a minimum. Now, we're not going to be graphing them all the time though, right? So how do we know if if our quadratic is, if it has a maximum or if it has a minimum, which is like saying, how do we know if it faces downwards or faces upwards if we're just dealing with the formula? So it comes back to the a number. So let's say we had our equation for the quadratic like this. Y equals, remember our generic form is ax squared plus bx plus c. So for downward facing, a is negative. So basically, the whole thing looks like negative x squared. Maybe there's some other number, but a will be negative. And then the quote unquote normal ones are when a is positive. Those are the ones we like. Those are the ones we practice with the most. And they're upward facing, and the vertex is a minimum. So here, same generic formula, but a is positive. Positive. Another name for the minimum or maximum. Edmentum is going to use this term, and other classes and teachers and books will too. It's called the extreme or extreme value. So these minimum or maximum values are called extreme values because it's like the highest or lowest point, basically. And if we're supposed to find the extreme value, think back to, I think it was Unit 3 when we were graphing parabolas, and we had to use this formula to find the vertex. So this isn't new, but it's been a while since we did it. Well, we did it together. So to find the vertex, we use this. X of the vertex is equal to negative b over 2 times a. And that's like the a, b, and c, a and b number. So we would use that to find the x value, and then you plug in that x value into the original quadratic to find the y value. And that tells you, remember when we were graphing, that tells you where the line of symmetry is and where the vertex is. I don't know why it shows up so much in today's mastery test, because it really doesn't have anything to do with completing the square, but they wanted to refresh us on that, I guess. So okay. All right, today's homework is to do number 3, completing the square in Unit 4.
Like the third assignment.
Third
in Unit
assignment,
4?
yeah, third mastery test, yeah.
Just the mastery test.
Yes.
Okay.
You can do the tutorial for extra support. I think it might even be more useful for you all to just go to YouTube, watch more examples from other people explaining it and doing it. If you follow along with it, I mean, even if it's not like making sense to you, but just work it out on paper. That's what I mean by follow along. Even if it doesn't fully make sense, just follow along anyways. Like, you all know how to factor with the lists. And you probably only know because we've been doing it so much, like over and over and over and over again. So getting some practice with completing the square, it'll start to make sense a little bit more over time. So I would just recommend getting some extra perspective on it using YouTube or Khan Academy, and try your best to just do it on paper along with the people on the video. Kind of like what I'm assuming you're doing with me now, is following along your best to the best you can on paper. Those steps we did, at the beginning. These are the same steps the other folks on the internet are going to be using. One thing that I did not really show you that you may run into is that instead of adding it to both sides, like, let's see, for example, 2 back here, we did plus 7. No, hang on. We did plus 16 plus 16. So instead of doing it to both sides, sometimes people just do a plus and minus together like this. So earlier we did this. This was example 2. So I'm just rewriting what we did in example 2. We added 16 to both sides after doing our cut in half and squaring and all that business. So some people may do it like this: x squared plus 8x. They add 16 and they minus 16. So instead of like doing it to both sides, they're just lumping them together. But see this, see how that's still the same thing? See how these will still cancel? Just like mine cancel the way I was doing it on the left and right. So it's just 2 different ways to do it. Now, if you do it the second way by doing the plus and minus 16 on the same side, when you factor, you leave that minus 16 alone. So we're just factoring the quadratic portion. Leave these alone for now. And what do we get? We get x plus 4 squared minus 16 equals 7. And then what do we do with that negative 16? We're still going to have to add it and move it over there. So I think I like my way better, but either way is like, okay. I'm doing it earlier and they're saving it for the end for some reason. Either way, we're going to combine the 7 and the 16. All right. It's pretty late, I think. I'm going to let you guys go. I've already got attendance down. Try doing the mastery test. And if you're feeling iffy, spend 10 or 20 minutes on YouTube or Khan Academy doing a little more of this today, okay?
Okay, have a good day.
It'll pay off. You too. Thanks, Braden.
Thank you, Josiah. Have a good day. I'll see you at 12.
Okay. Thanks, Leja, for coming back at 12.
Of course.
All right, bye.
Bye, Aaron. Oh, Maria, I'm sorry. Go. You can ask, but you're really, really quiet. I can barely hear you. A little bit better. It must be your microphone. Go ahead. What's your question?